Hello and welcome. I'm Bill Wake. We're here working on Parser Combinators. We've been at it for, well, this is session 12, so a few couple weeks, and we're mostly done. We're at the point where we're trying out our mostly complete system on some interesting grammars. And yesterday we did the dangling else problem, which is the system has to match the innermost else to the corresponding if. Today we have an ambiguity from basic, and it's a multiple statement ambiguity. So a line in basic is an integer followed by a statement, like 100 print. Okay. You can also have multiple statements on line if you put colons between them, and so statement goes to print integer. We're just kind of a minimal version of a statement there. But the interesting one is if expression then integer is sort of like if expression then go to whatever integer that line number represents. Or you can have if expression then statement, and then you can have multiple statements separated by colons. And so we have sort of a parsing challenge. If you broke up the top line first, line 1, you would say it's an if statement followed by a print statement. If you kind of went from the innermost one, you'd say it's just an if statement with two inner statements, and we want the innermost, the second interpretation. So I thought we would do that example, and then I think I want to just do some other just grammar rules, like maybe build a grammar for expressions and see how that goes, converting it into a tree and stuff like that. So get some practice with this. Okay. That's last time. So, oops. Let's see. So we had grammar tests. Let's close these other ones. All right. So here's our skip. We could make that a print. Oh no, other should be print. I'll rename this to print, just to kind of make this one a little more analogous. Oh, hey, nice to see you. All right. So this is yesterday's example. We define how do you match an other statement? Well, you turn it into a print. Well, let's make this print too. And print. And print. So I'm trying to make this more analogous to what we're doing today. But let's run that. Okay, so the grammar is, we're going to be a statement grammar. It's recursive because statements can contain statements. And we define the print. How do you match a print? And then how do you match an if clause and an else clause? So an if statement then is the if clause followed by a statement, followed by an optional else clause, followed by a statement. Okay. And the overall grammar is other statements. Let's rename that to print statements. So our grammar is, it's either a print statement or an if statement followed by a build if statement, okay, which is a function to map it. So up here is build if statement. Okay. It's basically taking the if clause and an optional else clause and turning it into an if statement with either both clauses or a skip for the else. All right. Let's define this grammar case for the other statement version. Let's see. So this is function test, basic multiple statements on per line. All right. Now our grammar is going to be somewhat different. Let's see. So let's just record it directly. So a line, do we care about the integer? I don't know that we do. let's let's just define it. Okay, let line parser equals, and we're going to match integer statement followed by multiple statements. Okay, so I guess we need a let's see. Let's say you are a well, I think I'm gonna have to do this kind of thing. Real life, we'd probably define something to help more of a helper, but okay. So let's let line number parser is satisfy, and let's just say 100. Okay, so we'll make that our input line, and we need statement. Okay, well, let's do a print. That should be the same as this one. Okay. And statement colon statement. Okay, there's print. Well, okay, let's bind up a statement parser. Okay. And I'm going to take the word parser off here. I don't know. Okay. So, all right. So we're saying statements are, we're sort of saying statements are a recursive type that input is a bunch of strings and the output is going to be a statement structure, which is up here. Okay. We're going to have to augment it for this example, but it's still the statement structure. Okay. And, in effect, I think we want to build the grammar kind of bottom up. So let's move this one down a little. Okay. And the print statement, okay. Then we have the if statement with a goto. So let's do that one. Let if goto equals well, you know what? I'm gonna make some helpers. We're gonna ignore the expressions again. It's just gonna be if expression then is gonna be treated like the word if, and then integer. Let's define a match function. Okay, I'm gonna put it up here. I don't know. I feel like I'm bouncing all over the place today. Okay, so this is going to be match. It takes a value of type string, and it produces a parser, I think. Right? I mean, this is a parser. Satisfy string. Well, that's true. It's a satisfy string. Okay, so we're saying this function, you're going to give it a value, and it's going to return you a parser. And so this is just return, well, we can leave off return if it's the only thing in this statement here. We're just going to return satisfy with $0 equals value. Okay, so it's very analogous to this. Okay, so I think I'm even going to substitute it in here. Let's see. Is this one breaking? Okay, let me back up. Pretend we didn't start this one. Let's improve the first one a little more. Okay, so let's say this is match print. Yeah, I'm definitely liking this. Well, if clause is match if, and else clause is match else. These two don't need to be used anymore. Okay. So the print statement, you match print and then turn it into a statement. The if statement, you match if and a statement, and then optional else statement. Okay. That should still work. Okay, so let's improve dangling else test. All right, now back here, okay, initialization's fine. This is match print. Okay, match print. Okay, and turn it into statement.print. Okay, if go to, well, it's this one is match 100. Okay. The if go to is, well, they both sort of start the same. Let's say an if statement. Maybe it's just if statement. Is match go to. I'm sorry, it's match if expression then. Okay. If, and then it's followed by and either match line number. I guess that's just line number. Or put this up here. Okay. It's match line number or it's statements. Okay, so it's statement colon statement, and we have a grammar we have a fancy rule for it. Okay, so it's statement, and then we use double ampersand match colon. Okay, and actually we don't really care about the colons, so we got this form that just takes the left hand thing. So they both have to be equivalent. Oh, interesting. Well, maybe I do want to split out if go to, because the statement match is going to return an array of statements, basically, and line number is not a statement, so they're not really compatible from the point of view of the alternation. So let's split them up. Let if go to equals match if and line number. Okay, and let if then or if state if then, well, if statements is match if and this. Okay, and I got one too many of these. Okay. If it's not statement, it's considered expression. Yeah, well, it's actually still a string. So this match line number, I suppose we could treat it as an expression. We could convert it to an expression using this pipe bar thing or pipe grader. like we did here, but I don't really have an expression type, so I'm just leaving it as the string. But in reality, yeah, we'd probably be matching tokens. This token is an integer token, and we would want to turn it might be some sort of expression. I don't know if we form expressions around those, but yeah, this is much more of an expression. So there, it's really a string at this point, which is incompatible with statement, because we said statements produce capital statement or type. And so the OR bar always has to have two things of the same type. And in this case, we had string versus capital statement, and those just aren't compatible. And so what I'm doing here, this if go to parser now, this is going to return an array of strings. This one's going to have a string and all this stuff. Okay. But both of those can convert to statements. Okay. And we'll need to do the conversion work somewhere in here. Okay. Now, interestingly, well, can we do that here? Okay, initialization is never used. Replace it. That seems like a wrong error. Okay, that's better. Okay, if go to if statement. Okay, now I think I'll make our line parser, and then we'll straighten out all these types. I mean, this is a big test. It's more an integration test, really, right? We're not writing any new code in response to this. At least I don't think we will. A line parser is a line number followed by, I think it's just statement colon statement. Okay, so statement, and in this case, ampersand match colon again. Okay, so this is the piece that's the same. The if statement or the top level statement have that kind of conflict. Okay, now what's your problem? Print statement was never used. Okay, and I have not defined statement. Okay. Well, let statement, maybe I will use the word parser here, it's either a print statement or an if go to or an if statements. Okay. And again, I think I will rename this just to print. I'm trying to avoid the word parser, but this one's funny, so I kind of feel like I have to. All right. Then we can do the bind here. Statement dot bind to statement parser dot parse. Okay. So we've got this incompatibility, but I think this is fine. All right, so line parser gets line number and statement and statements. Okay, and I think we probably want to do this, and that may mean this should have a higher priority than it does. It would be nice to write this without parentheses. Okay. Okay, so the problem here is this thing, again, it wants everything to be the same target type, but print produces a statement, match if produces a pair of strings, and match if statement this produces a tuple of a string and an array of statements. So they're all very different. Okay. But this is where we're headed. We want statements. Okay. So if line number, okay, now this is where I'm going to modify my structure up here. Okay. The if statement thing is fine, but it doesn't really handle the if go to. So let's make a new version that just takes a string. Okay, we won't worry about the line number too much, but all right. So if go to, let's see, let me close this one. Can I do that? Nope. I know there's a way, but okay. Right. So this one, print statement was never used. See, that's an old message. Come on. Okay. We get a statement here. Okay, this one, I would also like to produce a statement. And the input is the result of this match. Well, we don't really care about the if keyword because if we got here, we know we're in an if. So we'll just keep the line keyword, and we will do statement dot if go to with $0, which is the line number coming in. Oh, is it? Yes. Okay. And maybe this might read better like this. Okay, so match the if and the line number and turn that into an if go to statement. All right, and now this one is more complicated. Okay, once again, we don't really need the if keyword. So with this, again, we don't capture the colons. Okay, so this greater than sort of tells you who's capturing. And so we have an array of statements. Okay. And our if doesn't really do that, does it? So I think we need another statement type. Okay. And this usually gets called block, right? Block structured languages. It's an array of statements. Okay, so you can see where this indirect, right? This type is very recursive because if statements contain statements and blocks contain statements. And basically we want to build an if statement with a block. Okay, so this one, this one. Oops, no, it's this one. Okay, and I'm going to give myself some room here. Maybe a little less. Okay. The input is an array of statements. So what I want to do is I want to produce a statement dot. It's got to be an if statement because that's the overall thing we're doing. Okay, an if statement, and its first statement is a block of $0, which is the array of statements, and this one is a skip. Okay, because we're not doing anything on the right hand side. Okay, and I will indent slightly. Probably should line these up a little bit. Okay, so if you match if line number, you get if go to. If you match if with a block of statements, you get if statement block of those statements and a skip because there's no else clauses in BASIC. All right, now notice the error message went away because each one of these semantic routines, it produces a statement of some sort, and that gives us, okay, here's this line parser. Okay, and I think line parser wants to produce, I think maybe it needs its own type as well. All right, because a line has a line number and it has a statement. Okay, so This is building up this parse tree of possibilities, and we want to do the same thing down here. We want to make that correspond. So I need the line number, and I need, this is the array of statements. Interesting. If it was just one statement, I could put it in directly. All right, but okay, this thing is going to produce, it's going to be a statement. I don't know if I can just say dot, no. Statement dot line with, let's see if I can do this. I can say line number, comma, statements in. Okay, so the line takes the line number and the statements. I think that's okay. Operator and requires the types. Oh, yeah. Okay, that's got to be parenthesized on the whole way around. Okay, so I'm getting a takeaway here that maybe this should be higher precedence than this. But this is the same. Yeah. Okay, and I'm still getting a complaint. Ampersand n requires the type string and comma left to be equivalent. Target, statement, and match. Wait a minute. Is that true? Array? Oh, have we found a problem here? Okay, so this, well, this operator like this ampersand thing is really overloaded. Let's go find it. So I may have revealed an issue here. Left and then. Okay, so at the bottom we have all the operator ones. So we have this ampersand operator, and we say if you got parser 1 and parser 2 of the same type, then it's okay to make them into an array. If you have parser 1 and parser 2 of a different type, well, we don't restrict the type, then make a tuple. And if you have an element and an array, an array and an element of the same values, do this one. And if you have an element and an array, do this one. This is the one that's complaining. Okay, I think. Let's go back. Operator ampersand requires the type satisfy string, which is target. Let's complain about this one, string, and comma left bind to be equivalent. So this is array of target, which is statement. So I would have thought this should be string. I thought this should be a tuple, string and array, and it's not liking it. So let's see. You know, it crossed my mind at one point that I wondered if I could make a restriction that's like the tuple to say the types are different. Okay, so this one and then tuple, they have the same input, but I want to say P1 target is not equal to P2 target. Okay, so I don't know if you can make that kind of restriction. I want to say P2 target. I want to say not equal, and that seems like a risky kind of thing for the compiler. And I don't even know, is it not equal? Array of P1 dot target. Expected type. Okay. What I was assuming was, okay, let's take this out. These type restrictions, I don't, we'll have to find the real definitions. So, but I can say equals, and I think it's easier for the matching, right? There's a big algorithm to match when do two types correspond to this thing, you know. But maybe my array and then array. The input is p.input, the target is p.target. Parser 1, parser 2. Same input, same target. Okay, that's the array. I think this one, p1 target equals p2 target. We want and then element array. P2 target equals array of P1 target. Huh. Is this the one we're trying to match? P2 target is an array of P1 targets. But I don't think that's true in our test, right? Operator function ampersand requires a type string and array of student. But so I think it's matching, I think it's trying to apply this rule. But I really thought it should fall back to the tuple rule. Or else this tuple rule would match everything. Okay, let's do some research here. Okay, Swift where type. This is probably the right place to go. This is often a good thing. And the worst is I know they've been modifying this stuff. The newer version of Swift has got definite changes. Okay. A function type, parameter type T, that's not a where clause. Whoops. Where protocol composition. And I thought I'd be using these opaque types, but that did not seem to be the case. Were there only 3 matches, though? Generic parameters and arguments. Okay, I don't know why this didn't pop up, but okay, you can specify additional requirements with a generic where clause. One or more requirements where it conforms, inherits, or conforms. You can specify type equality. Notice you can't specify type inequality. Generic clause can appear as declaration. Well, that doesn't really tell me what's going on. Okay, so why is this not recognized? Let's make sure this is, let's see the usages. Okay, it's down here. Parser. And then tuple. I feel like, I don't know. It's so easy to blame compilers, isn't it? But I feel like something's going on like that. Something weird. Ampersand requires type satisfy string. Okay, that's this one. And comma left, array of comma left. Well, this is the comma left. Bind string statement, blah, blah, blah. Comma left is statements and strings, which his target is array. His target is statement. Okay, because statement matching, you know, this, I don't know, I don't have a good name for this operator, but statement separated by, maybe statement separated by colons, and we're throwing away the colons, so it just leaves the statement. So this target should be statement, and this should be statement, array of statement. And a string and an array of statements, I don't see that they conform to and then element array. Let's go back up here again. Okay, so the inputs are the same. They both start with strings, but the target, P2 target, is array of statement, does not equal array of string. I don't know. Now I can probably work around it, I guess. I mean, this is string statement. I mean, the right-hand side is matching array of statements. I could probably... I mean, I could turn this into a block, and it would just be a single statement. Let's try that. Let statement block equal this thing. Okay, and then to convert it, let's pipe it to, so this is an array of statements, so we certainly should be able to say it's statement dot block of $0. Like that. And then if I substitute that here, statement block, what do I get? Uh-huh. Okay. It's a little artificial. I'm mucking with my grammar to kind of meet this, but I think there's a good chance. I don't know. Like I say, I used to work on compilers for digital back in the day, and how many times we heard, "Oh, there's a compiler problem," and it was a problem the user made. But I'm feeling like that's a pretty clear violation to me. I don't know. All right, let's get through this thing. Okay, so I think what I've done this whole thing. I don't think it's my test yet. I think this is a basic line parser, and its type is parser. Do I have to say more? I think I need to give it a type. I think it's a parser. I think, what do we say? String to statement. And it returns line parser. Okay. So, non-generic type parser. Let's get to the definition. Parser. I guess associated types, it will infer them maybe. So we don't need to say them. Okay, this should build. Yeah, so much for that. Where is it not happy? Generic constraint because it has self or associated type requirements. Well, what's the type of line parser? Well, again, this is what I can do. Return bind of line parser dot parse. Okay, and I think his type is bind in type. Okay, so this bind is useful. Bind of string to statement. Is that accurate? Yeah. So one of the things bind does then is it sort of anonymizes the function. We have line number itself is a super complicated type, and I don't want that to be my return type. This is why I was hoping the sum type thing would work, SOME. I could just say it's some parser. You don't care. Don't worry about it. But a bind lets me strip that out and just be a parser from strings to statements. Whew. Okay, but this chunk of code, I mean, this is the kind of code our grammar is going to become when we switch to this in the interpreter. And now we can use it in an actual test. Okay, so we have a complicated thing. Let's write that test. Okay, func test basic multiple statement ambiguity. Okay. All right, so we need to create a parser. Well, that should be easy. Let parser equals this mess. Basic line parser. Is that. Okay. Now, if let input equal, it's an array of strings. Okay. And we want to take it from here. We'll do the simplest one, which I think this one is a good starting point. So put this here to remind me. Okay, so 100 is the line number. Then if a then print, then colon, and print, right? Okay, so 100 if a then print 1 colon print 2. All right, and we want to parse this. Parser.parse of input goes to, oh, can I, no. Result is that. To array slice? Really? I thought you were always allowed to pass arrays. I think you can do that. Okay. And now the assertions. Okay. Assert equal. Result is going to be a statement. And the statement we expect, which I hope is equatable. Yes. Okay. All right. We expect a line statement with a line number. Just a string, line 100, and then a block of statements, I believe, right? Okay, so block of statements. Okay. Can I refer to base and reference as no member line? Results are parse results. Did we call check success up here? No, we did our own thing. Well, we're going to do this kind of thing. Okay, so we're peeling out the success. If it's not a success, it's a fail. And then I guess we can assert remaining. That's fine. And then the target. And I'm just going to put this back here so I can put this back here. Okay. Cannot infer. Okay. So this this is not right because it needs all the if statement stuff in it, but it's enough that I can do an assert. I can run the test a little bit and see, and it should fail because we don't have the right contents here. But it should be the inner test, the inner one. So the block, okay, block element statements, if statements with a block. Yeah, okay. Let's figure out what this really should be. So if a then, so it should only have one statement in it, which is the if statement. Okay, so dot if statement. Okay, and the first one is the block of stuff. Well, the second one is a dot skip. We know that. Okay, the first one is another block. Block of statements. Okay, well, the two statements are a print followed by another print. Okay, so do we believe this? Let's keep formatting it so everything lines up just so, tree style. Okay, so it should be line 100 with a block consisting of a single statement. Okay, that one. Yeah, consisting of a single statement. The statement is an if statement. It has two statements inside it in a block and a skip. Okay, let's see. Wow. Okay. Good. I mean, it says it's working the way it is. It's supposed to, other than we had to do this little kind of compromise statement block thing. It I mean, another way to do this, right now, it just says, oh, you gave me a block of statements. You gave me a bunch of statements, I'll put it in a block. But if it turned out it was only one statement, we could just return the statement. So let's try that. The statement, so if state, if $0.count is 1, return $0 sub 0 is a statement, else return this. All right, let's format this. And really, I should be putting this in a new routine at some point. But okay, if this, then return that. Oh, he's not happy. Else formatting. I wish it would work for me. Else first one, second one. Goodness. Okay, and this matches that one. All right. So cannot infer return type with multiple statements and explicit type to differentiate. Really? Okay. Let's just make a make block. You give me statements is array of statement, and I give you a statement. All right, and that'll make this less. It'll be clear what the return type is. Okay, if statements return sub 0, else return block of statements. Okay, and we use that. Oh, I don't need the braces anymore. Is that going to work? Yeah. Okay. So I'm saying if it's one statement, just return it. Otherwise, wrap it in a block statement. And that's make block. Okay. And so that should change my answer here, because if the if statement is the only statement in there, so this block goes away. And it had a corresponding, is that right? If statement. Yeah. Okay. So that's my claim. Yeah. All right. So just trying to get a feel for the kind of semantics we got to give these things. But this is nice enough. I mean, we could live with the blocks, of single statements, but they're not necessary. What it does in the tree, it gives us a way around the fact that these can be statements, could be arbitrary lists of things, and same thing here. Okay, so let's push this. We added test for basics ambiguous multiple statements. Okay. What I want to do, let's see. I want to do two things. Well, three things. All right. So, yeah. So we did a simple test. I want to do another test. Make sure nested ifs tie to innermost if. Make sure nested if statements tie to innermost if. Okay, so I think we've done this one. And I wanted, let's capture that. 22-12, August 3rd. Okay. Cool. And then we want to do that one. Semantics for expressions. I do want to do that if it happens tomorrow. But I think we should isolate the ambiguous operator issue we saw. Okay, so I think I want to report that. I mean, I may get dinged like, you just don't understand. But I'm still surprised because I do have tests that rely on this tuple version, so it gets tuples back. And yet it seems like it's trying, what I think should happen is it looks at this and an element array and says, I can't match that. This is not an array of that. It's an array of something else. So this whole thing doesn't apply, but that's not the behavior we saw. So, it's worth checking up on. I'm not sure what the process is with Apple and bugs and stuff, but, and they may say like, what language are you using? 5.6? We're not caring about that anymore. Bring down the new version. Okay. But anyway, let's see. So we have the one test done. We can use that same parser in the next test. So let's put the stub of the test, and then we'll I guess let's copy the test. Okay. Basic, how about nested if statement ambiguity. Okay. So we got our parser. I want to do if A, then if, I'll do a print, and if B, then print 3. Okay. So it's sort of the same problem, and I don't anticipate an issue with it, but I want to make sure that the overall statement, there's one statement, this giant if A, and this if A, if it's true, it has two statements, print 1, and an if B, print 2, print 3. So this should be bound into the if B, not in the if A. Okay. So we tested ambiguity between the top level and the if statement. I want to now test ambiguity kind of across if statements. All right. And we'll need to modify this test result. That's going to be different. Okay, let's take a break, like 3 minutes, and we'll come back, implement this test, and then see if we can isolate, create a little test case that demonstrates the ambiguity issue we're seeing in operators, and maybe report a bug to Apple. And otherwise, The other thing that happens is I isolated and realized, oh, I was stupid. So, there's a distinct possibility of that. I'll see you in 3 minutes. Hey, welcome back. Alrighty. Let's see. So let's encode this in our input. So line 100, if a, then print colon, and then we need the if b. If b, then print. Is that right? Okay, 100. If a, then print colon. If b, then print colon. If b, then print colon print. Okay, that looks right to me. All right, now the output of it. Stretch this a little down. Okay, and all right. So line 100, if statement, which has a block. Because it's two things. It's a print, and its else clause is a skip still, but the second statement is another if. Okay. Print, and this is an if statement, and it's contents is a block with two print statements in it, and then its second piece is a skip as always. Okay, let's see, have we got it? Okay, line number 100, if block of print and an if. Yep. The inner if is a block with print and print. What's the matter? Statement to statement has no subscripts. Oh, parentheses. Print. Okay, end of that, skip. Okay, and I think this should just pass. Yes, okay. Could have done it before the break. All right, so added test of if statement pulling innermost statements. I don't know. It's a little ambiguous to me, but we did it. Okay. Feeling good then. That's probably the ugliest syntax thing in BASIC we have to deal with. I think everything else is there's some ugly pieces in the well, matching integers versus line numbers. That's a little tricky. And I think there was a bit in the data statements, like it could be strings or data, and it was kind of ambiguous there. But I think we probably have the worst part done here. At least that's for now. All right, let's make a new test. Okay, and this is test suite. Yeah, that's the case. XC test. Okay, this is operator type match tests. All right, I don't think I need a testable import because I'm not going to reference anything on that side of things. Okay, What I am going to do is include a bunch of stuff from and then. Oh boy. All right, let's try and do tuple. I don't know. This that file should be renamed. Maybe I do need my testable import. For now, I'm going to strip stuff out and try to make it not care. Okay, so theoretically, I just need this one and then element array. Okay. So that, and then the operators. So and then array and then tuple. And then element array. Now I can't believe it hasn't complained. So let's do a build. Right. Okay. Let's make our own operator though. Let's do how about a triple ampersand? Now I thought I would complain about these types being repeated. But it's not. Okay, so I haven't broken any existing tests. I don't want to do that. Oh, test 0. Executed 3 tests. Okay, this test fails, but everything else is good. Okay. Whew. All right, so let's see. The situation we had, which I probably should have saved somewhere, huh? It was, let's build up this. We'll borrow this thing too. I need match. Okay, fine. Okay. Make block. Right, we needed make block because of that. So we had line number and statement and match. Okay, let's take this out. I don't think we need that. Okay. Operator function requires target be equivalent. Yeah, so reading the error. And then this, I think I can skip. And my message went away. Let's skip this. Wait a minute. Satisfy string. And comma left array target be equivalent. What's going on though? This closure target goes to statement. String to statement expects one argument. Why does commenting out this fix that? I shouldn't judge. No. Type of line parser is a tuple. What the heck? Okay, so line parser, so the parentheses there is saying it's a tuple. It's a anonymous thing. The first argument is a, oh wait. Wait, where's the string statement, comma left? Satisfy. Okay, it's an and then tuple. I don't know what the parentheses are on this thing then. Line parser is an and then tuple, which first one is a string, and the second one is the bind. And an and then tuple should produce. Okay. Let's see if we can get the type of this thing figured out. Parse result. Satisfy input. Okay. I think this is a tuple. Okay, can I tell from here? Bind his satisfy strings input is string, and then it sure looks like a tuple. Okay, well, what if I pipe this into print $0? Can I do that? Cannot call value of non-function type pipe of satisfy string statement. Generic parameter in cannot be inferred. Expects. Oh, okay, sure. I don't know. Now, foo's type is bind tuple. It sure looks like an and then tuple. Why did I have problems before? So I sure thought this would be a tuple. This should be a line number. Let's spell it different just to make sure it's showing up different, and an array. In statement.skip. Okay, it should complain about not using them, but that's harmless. Hopefully they match. Build succeeded. How's that different than this? Okay, statement dot line num array. Okay. Contextual closure type string expects one argument, but two were used. Satisfy string target goes to statement. Does require string and comma left to be equivalent. Yeah, now I'm back to this. It's so weird. Oh, maybe this thing is not flexible enough. Because, like, changing the type of this, I don't know why it should care, though. But changing the type of this from skip to line somehow makes this no longer valid, right? So, let's see. I had pipe to line number array in statement.skip. Okay, and then do that. And I think that should build. Okay. Line number and statement match statement separated by colons. Statement separated by matching colons. Pipes to line number array. So this pipe to line number array, this is my argument, the type of this whole thing is producing a tuple, line number and array. Now we can't tell that the array is really an array, but something's going on. And then if I comment this one out, put this one back, which is the same as this one, so let's just take that out and build. Now everybody goes crazy. Operator function requires type string satisfy be equivalent. Pipeline number array, and this thing is messed up. He says, no, I really just have a string, but you use two arguments. That's no good. Okay, let's go look at this thing. Pipe. All right, now pipe doesn't really restrict things. Okay, so this is, you give me a parser Well, let's see where it's used. Okay. If you give me a parser and a function, I will give you, I'll call the pipe with them. Okay. And the function goes from the parser's target to some sort of value type. In our case, V is statement. Well, we could cut out the middleman. Oops. I mean, I could say pipe of, whoops, pipe of line number is the first argument and the function is the second argument. Well, let's take this one for now. Pipe of and then tuple. Okay, V is statement. That's correct. And then tuple. It's still got the tuple. It's okay. Now let's substitute this one. Wow. Okay. String to statement. Comma left bind. All right, we are still using our old type. Let's try the and. Let's try this operator. And that. Is that going to matter? Oh. Cannot convert value of comma left bind string target to expected type statement. Array of statement. Oh, well that could certainly be a block. So that's okay. All right, let's take it back. So, like I said, I was a compiler team. This is the kind of stuff you end up doing for support, right? Because somebody gives you this horrible program and says like, oh, it doesn't work and it's your fault. And you try and isolate it down. Okay. So what that tells me is maybe I need to, let's make this block of array. Block of array. And let's try, oh, that's with this operator again, it's happy. Wow. Okay. Line number array and statement line number block array. Okay. That looks the same to me. All right, let's take the pipe operator out, or we'll put it back in, but let's use the operator form. Pipe to this. Build. Bang. Oh, no comma. Whoa. Okay, that builds. So I think it's not. I mean, I was definitely suspecting the type matching, that it was coming back with the tuple when it shouldn't, with the tuple or whatever. I think it's really more a question of error messages than correctness. I mean, this statement line with just array was clearly wrong, because we needed a block in there. And I think maybe, let's see, so you're doing it right when you can take away one thing and get what you expected. So the difference between these two, one has the block and one doesn't. Okay, now you're not gonna complain? There you go. Okay. And this is getting a statement has no member type array. Whoops. Okay, now we're getting that. Okay. It expects, yeah. So I think the problem was the real thing is this is missing the statement line is malformed because it does not take an array. Let's see, only the block does. Let's see, where's that thing? I guess it's in here. Okay. This one is the only one that takes arrays of statements, so I can't pass an array of statements there. Yeah, so if I put dot block array back, whoops, back, build, should build. Okay, so I guess my complaint is no longer that it looks like the operators are mixed up or something like that. My complaint is really like, oh, the error message is completely bizarre, right? Because the immediate problem is statement.line takes a line number and an array, and takes a line number and a statement. We treated array as a statement, but it's really an array of statements. And if you don't have the block there, this is an array of statements. And then somehow it gets that message that has nothing to do with the statement line being messed up. It's all about the operator being messed up and stuff like that. So it's back forcing. I don't even know how that could work, right? Because array has to be a statement. So yeah, maybe it's working that way. It says, okay, if you don't have block here, array has to be a statement. So if array is a statement, then this thing has to be something, and it can't be that if the only way that'll work is if this is not an array or something like that. So okay, so let's take this out. Well, actually, let's apply our knowledge back here again. It was basic line parser. Okay, statement bind, statement block, make block. Oh, this one. Well, no, that looks like what we did. Statement. Okay. Yeah. So I think we can put this back. Okay, let me not screw everything up. Okay, let me make a new parser. I know we can get it back from source control, but let's just do this way instead. Okay, so this thing, we didn't have make block before. We had this in parentheses. Okay, line number, statement, match. We're getting that message. Okay. Now statements is an array of statements, so this needs to be block of statements. Block of statements. Oh, we don't want to make block anymore. Oh, we don't need statement block anymore. Okay. Expected parend. Statement line number. Block of statements. What's your problem? Line number. Oh, there we go. Statement match one more. Okay. All right. So I don't need this. Okay. I don't think it was necessarily terrible to have that make block there. I mean, we can still use it even, right? It takes an array of statements. Let's call it here, make block statements. Okay, so now if I didn't do that, I would always get a block. Oh dear. Okay. I would always get a block, and really, we said if it was a singleton, we'd just as soon have one statement. Okay. Now I'm going to use Parser 2 in here, run these tests. Unk. Operator match test. Oh, yeah. Didn't we delete that? I guess not. Okay, so basic. Let's do it here too. Okay. All right. Now no one's using this one. Let's delete that. We'll rename this Parser. Okay. Now, I would say, like, I expect that something this complicated probably belongs in a method, and we can deal with that. You know, for testing purposes, I'm fine to use blocks like this because it keeps everything in one place and you can see what's going on. But, all right. So I think everything's green, right? So let's check it in. All right. Figured out we were missing a block and got a strange error message because of it. We had suspected an operator type match bug, but it's really a weak error message. Okay. Good, and we got a leftover file here, operator type match tests. Let's get rid of this. It served its purpose. Okay. So my mission at this point, um, let's do our to-dos. Okay, make sure nested ifs tie to this. Yes. Um, good. Isolate the ambiguous operator we saw. Yes. We're getting a message from the operator when the issue was really that a piped routine had an argument mismatch inside it. Okay. All right. Semantics for expressions. Okay. I think that's where we are, is working with expressions. So I think what I'm doing, I'm sort of doing integration testing on this, because I'm not changing anything. I mean, we suspected a problem, but it was in our code up here, our test code here. I'm using all this stuff, but I'm not changing any of it. I'm not generating new code or anything like that. So it is much more of an integration test. The other one I wanted to do was handling statements. So with the parser combinator, in effect, you're building up the parse tree as you go, but like, because these grammar operators, let's get back to that one, like this statement and match colon, it doesn't really do anything until it's got the array of statements. So that expression there gives me an array of statements. They were separated by colons. I don't really need the colons for further processing, so it just keeps the array of statements. But it's not giving me any chance to I can't modify the statements as I go. So like, I couldn't sum, if it was a series of numbers, I couldn't sum them. I'd have to wait till I get to the end and then sum them. And partly that's, maybe it's partly difference in philosophy, but I can build up, like, I'm building up statement becomes a statement, and if is still a string. So I'm allowed to mix these types if I'm careful about, dealing with ignoring the one, or making sure when I compare, alternate them, they're all the same type. If I keep those rules, then I can do this stuff. But I think, like, expressions, where can I write? Okay, so in the normal grammar, you do like term goes to factor, and then you can do repeat. In our terms, it's like star, and then you could do star or slash factor. Okay, so I'm kind of mixing our notations, but a term is one factor followed by zero or more times or divided by factors. Okay, and factor can go to number or variable, let's say. Okay, there's other stuff, but that's the core of it. All right. Could be an array, could be a function call, whatever. So with this form, I mean, in the interpreter, we would recursive descent. We'd write something like this. Function. We'd make a term, a function for each rule. Okay, function term, and then we would call let result equal factor. Okay, and then while token equals star or token equals slash, so the star operator turns into a while loop. Okay. Then you would do let operator equal token. Oh, we'll just say op. Let op equal token. And then we need to call factor again. Let result 2 equal factor. All right. And then in recursive descent, I would probably do result equals operator 2 of op and result 2. Okay, so I would accumulate the expression as we go, and this is this kind of handles the precedence, right? Because the star, A times B times C is really A times B times C, and so we're doing A times B, and then come around again times C. So it builds up the tree properly for a left precedence, left associativity, I should say, because they're the same precedence. So you'd write a method for each of these things, and then at the end here you can return result. You've accumulated into an expression because factor is going to return either. Well, we can write factor if token equals number, then return dot number with token. Else, if token equals variable, then return dot variable of token. So you're shifting from the token domain variable to the expression domain here. Okay, so this is a token, this is an expression. This thing returns an expression, and this thing returns an expression. Okay, so so what you get with recursive descent is if your grammar's formatted right, then all you have to do is you see a left-hand side, you write a method. You see a reference to a different left-hand side, you write a function call. You see a star like this, the loop, 0 or more, then you write a while loop. You see a token to match, you check for it, and so on. It's very straightforward. This one, number or variable, well, it turns into an if statement, But what we do here is we've accumulated this result. It's going to be different in combinator land. We define this match and we get back, well, it's going to be like, what's it going to be? It's going to be a tuple consisting of a factor and an array of tuple of operator and factor, something like that. And the whole thing is there with the array completely filled of all the stuff. And we have to walk through the array and in effect repeat this loop to build up the results. If it were right precedence, right associative, we'd walk the array from the right. And so the grammar doesn't have to care about what the precedence is per se. The associativity, we enforce that in the semantic routine. Okay, so hopefully, that's a crash course in recursive descent. Now, what I want to do is I want to make myself write that semantic routine. Okay, so let's define an expression type. Okay, so it's gonna be like this. We'll do the same thing here. Okay, indirect, let's make an expression. Okay, and expressions, well, they can be number which will give it a string. We really probably convert it to numbers and stuff, but that's okay. It could be a variable. And again, we'll give it a string for the variable name. It could be a binary expression. I'll say, I don't know, op2 is what I usually say, but op2 and op1 is unary and op3 is triples. Op2, well, this is really like expression plus expression, expression times expression. Usually they put the operator first, but I'm going to live on the edge here. Let's put the expression string for the operator and expression. Okay. So this gives me a type that it's either a leaf, which is number or variable, or it's a interior node with a left-hand side and a right-hand side and an operator in the middle. Okay, and I think that's all we need. All right, now the grammar. Well, this is probably reasonable. All right, so let's build a parser first. Function expr parser. And it's going to produce, well, let's worry about that later. Okay. All right. Well, we know we need to match. Let's just make all numbers be 100 again. So case, let's let number equal match 42. Let var variable equal match x. Okay, and then we need a expression. So let expression equal bind. Input is string. String. Output is expression. And we don't have the contents yet. Okay. And so an expression, well, let's let term, well, let's do factor. I think we can, oh, yeah, where it gets interesting. That's probably the interesting case. That's what makes it recursive. Sorry, nah, it's recursive from this in a sense, but this one really brings the recursion back around. That's why we need the bind. Okay, so I think now we can say let factor equal number or variable or match left parenthesis. We'll ignore the parens because we now have the interesting informations on the right, the expression, and then we'll ignore the right parent. Okay. Now, the reason the complaint, it should complain, yeah. The types don't match. These two are strings, this one's an expression. All right, so let's convert these to expressions so we can make them all the same type. All right, so this goes to dot number of $0. This one goes to dot variable of $0. Okay. And that should be happier. Cannot infer contextual reference to number. Okay. Expression. Okay. Yeah, so we haven't used it, but right. Okay, so that corresponds to this rule. So you can see my recursive descent, I had to write all these while loops and stuff like that. I'm not doing that here. I'm actually mirroring the grammar pretty closely. All right, so I got a factor. Now let's make a term. Well, a term equal, and in our notation, this is factor ampersand ampersand, no, yeah, ampersand ampersand match of star or match of slash. Okay, that's these two followed by a factor, and followed by is ampersand. Okay. Okay, so factor, again, well, I'll move the grammar down. Put it down here. Okay, so term is factor followed by, is that my right operator? Yeah, so that's this thing. It's followed by these separated by those. Okay, so followed by is a factor followed by, oh, no, I am doing that wrong. I don't need this. That's built in. Okay. I feel like I got one extra paren there or something. Match, match, yes. Okay. A term is a factor followed, well, in our case, we're saying separated by either stars or slashes. And the type of this thing is going to be complicated. Okay, like I said. It's building up the whole thing. I don't know. I'm afraid, my fear is these types get so deep that at some point my system just goes like, I can't tell anymore. Your grammar's so deep, I don't know. But anyway, this is factors are separated by star or slash, okay, which is the same as factor is followed by 0 or more cases of star slash followed by factor. Okay, the long way around. Okay, now our expressions, expression dot bind. Okay, the function we care about is term. Parse. Okay, and then we will return. Cannot convert value of. My goodness. Okay, we're definitely seeing the downside of this approach. Yeah, the problem is it wants expressions, but nothing is converting a term or to an expression. Okay, so number maps to an expression, and variable maps to an expression, and this expression, ignoring the parentheses, maps to an expression. So factor maps to an expression. But this maps to a mess. It's a tuple of factor and blah, 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 blah. Okay, so we have to provide the matching function for this. All right, and again, it makes me wonder if my precedence is quite what I wish for. All right, let's do, we're going to set to a function. Well, the function is going to be, I'll just call it toExpression. Okay. Yeah. Okay. Now, toExpression we haven't defined, so let's define that. toExpression. It's going to take something and it's going to produce an expression. That's the good news. All right. The bad news is, what's it going to take? Well, it's getting the result of this. And the result of that, I believe, should be a tuple of an expression, because it's a factor, which is an expression. I don't know if I can write it this way, but I'm going to say factor 1 and then array of type tuple expression and array of something. Well, what's the array of? It's an array of strings and expressions. So the string is the operator and the expression is the second factor. Okay. Do you buy it? You pull it by colon. toExpression. Oh dear. I can't do that there. Okay, we'll talk generically, argument of that type. And let's just return number 0. Okay. Int toExpression type string, sure. Okay, so I'm just stubbing that out for now, but I've got the type right. It takes the result of this factor, ampersand is one expression that's the factor, and then an array of operator plus the other factor, which is an expression. Okay, and everybody's happy here. Okay, so factor was never used. That's not true. Well, I guess we're going to return expression. Okay, so the type of this thing is, well, I think again it's bind, string, and expression, kind of by analog to what we did before. All right. I still feel like there ought to be a way to express it as a parser, but I don't see it. I don't know if that means I should have made parser a generic instead of a associated types. I don't know. All right. So once again, we've done all this stuff. This is sort of a realistic but not real expression parser, right? It's very minimal. It's only got two levels. And now we're going to use it. All right. And I don't know if we can call check success. That would be nice. All right. So let's make a test. Okay. Test expressions. All right. So if I let the input be, it's an array of stuff. Let's just start with a number. Okay, so all our numbers are going to be 42. And if you say expr parser dot parse of input, and you catch the result. Okay, cannot convert input dot dot dot. Okay. And we should be able to say result.check success. Target is expression dot number 42, and remaining should be empty. Cannot convert value of type void to input of expected type array slice string. How to do that? Okay. This test should pass. Dum-dum. Okay. Number 0. Oh, yes, it should fail. We never implemented our method up there. Okay, so, oh boy. I guess this gives us an excuse. All right, so I could just return, I could say let factor1 array equal argument. So I'm peeling apart that tuple. And then I could just return factor1 and this test would pass. Sorry, no dot. It's an expression. I want an expression. So yeah. And it's just happens to be the one expression that works. Okay. I'm going to make this more complicated. I'm going to test X. Well, I'm going to get to more complicated tests, so I'm not going to worry about keeping this little test around. This should pass too, because we haven't done any operator stuff. So shows what I know. Oh, it's not number, it's variable. Variable. Okay. And then more interestingly, I want to do parentheses. Parenthesis, X, right parend. Okay. And we throw away the parentheses. When we parse it, because they're just setting precedence. Okay. So this should work. I'm not as sure. I can hear my body telling me. Okay, it does work. Good. All right. Now, let's go back and make some real stuff. Okay. So if we did X times 42, okay, we would expect an expression of op2 variable X string times and number 42. And yes, my input's still empty. One more parent. Okay, this is going to fail. It's weird. I mean, this is like, I'm almost like doing TD on my test to drive the correctness of my test helper, but in reality, I'd be driving code with this. Okay, it should fail, right? Did fail. Good. Variable x. So it only picked up the first term, as you'd expect, since it never even looked at the array. Okay. But now we can get there. So let result equal factor 1 and return result. Okay, that's an empty refactoring. But let's do for each thing in the array dot for each, and the body is, well, we're getting an operator and a factor. I'll say factor 2 in this. Okay, what are we going to do with it? Well, what we need to do is assign result, and it's going to be a dot op2 with factor 1 op and factor 2. Now we come back around. Make this a var. When we come back around, the result is the latest version of this thing, the innermost pair. So we get our left associativity, and we can append the next one, the next one, the next one. All right. So I think we can make this thing even more complicated. Divided by x. Okay. And then this expression.op2, it's going to be an interior one. Expression.op2 of this. There's the op2. The operator is divide, and the last argument is a variable x. Make sure that matches op2, and then success. Okay, so let's see if this works. I probably shouldn't have jumped the test forward, but yeah. Okay. Op2, variable x slash x. Okay. I recant my test, revise test. Let's do one test at a time. Take out the slash x. Test is still going to fail. I'm predicting. What do I know? X times 42. We got our op2. Oh, factor 1 should be result. Well, let's write the test and see it and make it pass. Okay, this time I'm going to put my slash back in. And an x. Okay. So this should be the inner one. The outer one is this one, followed by a slash, followed by variable x. Okay, that matched. Good. This test will fail. Oh, not quite what I had in mind. Okay, I predict we'll get our XX thing again. Funny, when it passes, it's so fast. Okay, we got op2 x slash x is not equal to that. Yeah, because I didn't result, factor 1's gone away. It should be result now. So we want the previous result to be mapped in, and this should pass. All right. Wow. Okay, but this is, it brings out interesting things. I mean, I like the fact that this indirect enum, which can be recursive and has these associated values. I mean, this is this is a moderately complicated data structure, and yet it's very concise to specify it. So that's cool. The grammar rules map very closely to the grammar rules that we would write, as a language designer. That's cool. And the worst thing is when we see problems and we're trying to figure out what the heck is going on, we get some horrendous expressions. Occasionally it simplifies them for us, but not always. Now I think I could probably take out this expression. I mean, that should build. I might be able to take out this one. Oops. Yeah. Because it knows the type should be expression. All right. But yeah, this is a very classic kind of thing. Now we've dealt with. I don't know. Should I put another level in? Maybe so. All right, let's do we're gonna grow our grammar. I forget what you call these. You got factors, terms. I don't know. I'm gonna say sum is term followed by either star or, sorry, that should be plus or minus that match 3, and then I think I get by with this. I think I can just say to expression again. Okay, because to expression, it doesn't care what the operators are. It's just saying you've got a sequence of operators that are the same precedence, and I'm just gonna put them in. Okay, so instead of term.parse, let's do sum.parse. We're saying we would accommodate expressions with pluses and minuses. Our existing test should be fine though. Okay, because we don't have any pluses or minuses, so it just goes down the term branch and does the rest. Okay, but that lets us get a precedence test. Expression precedence. Okay, so if I do x plus 42 times 42, okay, x plus 42 times 42 should compute the 42 times 42 first, right? Now if you took the way we're doing the previous one with the left associativity, it computed the first two terms first. So let's check. We should have an op2. We should be adding a variable x. Variable x. Okay. And its operator is plus. And then its sum stuff is up to number 42 times number 42, and extra comma. Let's see, check success. One more. Up to, yeah. Okay. Whew. Okay, so x plus 42 times 42 should give priority to 42 times 42, even though the natural left precedence way would be to give priority to x plus 42. Okay, so x plus the product, and this should pass. Yeah. All right. Cool. All right. I think this is probably a good place to stop. Tomorrow, uh, we'll pick up. I think I've done enough semantics for expressions. I see how it's kind of working. Um, the cool thing is this to expression, I don't have to write one for pluses and one for times and one for exponents and all that stuff. So that's cool. Um, I would love to redefine my parser, and I don't know. There's a way to do this stuff. Okay, so anyway, yeah, tomorrow same time. I think what we'll do is we'll just take a walk through, just kind of top to bottom, and make sure everything looks good, and do a wrap up, and then I don't think anybody's gonna. I mean, anybody wants to look at it, that's fine. They can learn something from it, but let's do a code walkthrough. We may think of some more test cases, but we'll do a code walkthrough and see if we can clean up some test cases, maybe. I don't know. And wrap it up. That's the Parser Combinator. I'm gone Friday. Yeah, same time tomorrow, 10 a.m. Eastern to 12:30 p.m. or 3 to 5:30 p.m. UTC. I'm out on Friday, but I think we'll basically have finished this project. We may even stop a little early tomorrow, but we'll get this thing published on GitHub, and next week we're going to integrate it in to the compiler we've got, or the interpreter. Okay. Yeah, this code's definitely on the obscure side. I mean, with the grammars and stuff like that, it's definitely not your day-to-day stuff. And the operators and all that usually work with that stuff that way. So it is a little different. But I don't know. I'm pretty happy with this. Like defining this stuff. That's like 3 pages of recursive descent code. So I think it's going to be a good change. And so my goal next week is I've got this parser. Let's integrate it in to the old system, and switch over to this parser and go from there. I think that'll take maybe a week, maybe 2 weeks. We'll see. And then I've got a couple other refactorings I want to do on the interpreter. I want to turn it into a compiler. That's kind of my big one. And we'll see. So it generates Swift code and turns BASIC into Swift. But thanks for joining, and especially Shebang there. I appreciate you hanging in there with us, and catch you in the future. So have a good evening. Bye-bye.